We're going to look at volumes of revolution. So in the textbook, this is chapter 7.3. So if we have a area, so let's take this area here, and we'll assume that this curve is f of x. Okay, strange looking curve, I know. And then what we're going to do is revolve this 360 degrees around the x-axis. Oh, sorry about that. Dropped my pen. Okay, and so when I do that, if you can sort of imagine this, you're going to get like this three-dimensional, so I'll just draw the x-axis there. And so you're going to end up with from A to B this sort of shape. So what you're doing is think of taking that two-dimensional area and then just repeating it in a rotation all the way around to make this volume or solid. Okay, and then we're going to look at a small section of this. So if you want to think about just like cutting out a piece of that, what that would look like, it would be like if I had a whole bunch of CDs all together, right? I could curve them so they make a shape, and then when I pull it out, I would have this like mini cylinder that there was the x-axis. And to get the height of that cylinder, you know, it would be f of x, right? That would be the height of it. So that would be the radius of the cylinder. So that's the radius. And then the height of it would actually be the change in x. So we'll just call that dx, because we want it to be so small that there's just, you know, an infinite amount of these discs making up that shape. And the more discs we have, the smoother that curve is going to be in that solid. So, you know, let me just see if I can make this more three-dimensional. So there's like, I have a small disc here. And then the volume of a cylinder is equal to pi r squared h. And so in this case, it's going to be pi. The r is f of x squared, and the height is the change in x. So if I sum all of those up from A to B, I should get the volume of revolution. Okay, so again, this is going to be the formula. So in the next video, I'll do an example.